Hello everyone, welcome back to my channel. Today let's learn the topic sets for class 11. Okay, the main topic today we are going to discuss is subsets. Okay, first let's see the definition of a subset. A set A is said to be a subset of set B if every element of A is also an element of B. Okay, I hope you have understood the definition. We can just see this with an example. See the picture here. We have taken two sets, set A and set B. Can you see the diagram here in the blue color? See, set A is having 1 and 2 and 3 elements, where subset B is having 1, 2, 3, 4, 5. This is set B is having 5 elements and set A is having 3 elements. Whatever the elements are there in B, the set A should be having the same elements. Okay, then only we call it as a subset. In the diagram, we can tell A is a subset of B. Okay, then next, how we are going to represent this subset with the symbol, this one. This is a symbol. The symbol, this stands for subset. Okay, and we can also tell it as a subset or contained in. In other words, we can tell A is a subset of B if whenever small a belongs to set A, then small a belongs to set B. See, when we are considering small a as the element of A, then set A, then the small a should be in the set B also. Then only we call that as a subset. Okay. Then it is often convenient to use the symbol, which is this is what which implies. Using this symbol, we can write the definition of a subset. See the definition here. A is a subset of B if small a belongs to set A, which implies small a belongs to set B. Okay, you think set A is also having the element A and set B is also having the element A. Then only we are going to call that as a subset. A is a subset of B whenever both the sets are having the same elements. Okay. Next is, see, if A is not a subset of B, how we are going to write? This is the way we have going to write subset, strike out, and then B. A is not a subset of B. Next, if every element of B is also in A, then we call that B is a subset of A. Okay, then in this case A and B are the same sets, so then we call it as A is a subset of B and B is a subset of A, which implies A is equal to B. Okay, this is a symbol for what? Two-way implication. Both if A is having 5 elements and then B is also having the 5 elements, the same elements, then we call A is a subset of B and B is a subset of A. Then we can also write it as A is equals to B. This is what? This is a two-way implication. Okay, and this is a symbol we are going to represent. And it is usually read as what? If and only if. It is briefly written as if. I hope you are clear with this subset definition. Let's take some examples and it will be very clear to you. A is a set of all divisors of 56. What are the divisors of 56? When we divide 56, see, we can divide it by 1, 2, 4, 7, 8, 14, 28, and also 56. We can divide it these are the what divisors of 56. And B is what? The set of all prime divisors of 56. What are the prime divisors of 56? These are 2 and 7. Okay, 3 times 2 and 7. Now you tell me B is a subset of A or no? Yes, it is a subset. See, the elements 2 comma 7 are there in set A also. In B we are having 2 comma 7, and even in A also we are having 2 and 7. Then we can call it as B is a subset of A, and we can write, see, B is not equal to A. You just see, we are having only 2 and 7 elements same in both the sets. We are not having the other elements. We are not having 8, 14 and 28 in set B. Okay, so we can tell that B is not equals to A, but only B is a subset of A. Okay. Then next, let's see the other example. Let A is the set A is A, E, I, O, U, the elements, and B are small a, b, c, d. Now you tell, is a subset or no? A is not a subset of B. Why? Because there are different elements. Compare A and B. Compare A and B, A, E, I, O, U. And here we are having A, B, C, D. A is not a subset of B because they are different elements in both the sets. And B is not a subset of A. Okay. Then next, let's say A and B be the two sets. Okay. If A is what? If A is a subset of B and A is not equal to B, it's only A. Just we have seen the first example here. Okay, prime divisors of 56. Okay, if A is a subset of B and A is not equal to B, then we call A is what? It is a proper subset of B, and B is called the superset of A. Okay, then this we can see with an example. See, if A is equals to 1 comma 2 comma 3, and this is what? It's a proper set, and B is what? 1 comma 2 comma 3 comma 4. This is a superset. Okay, A is a subset of B, and we call this A as a proper set and B is as a superset. Okay, if set A has only one element, we call it as a singleton set. Okay, then this, see here, thus we write as a singleton set. I hope you're clear with this. Now let's solve some examples. See, let's take one example. Let A is equals to the ovals A, E, I, O, U, and B is what? A, comma B, comma C and D. Is A is a subset of B? The question is A is a subset of B? You have to answer. No, it is not a subset. We all know that because A is having the different elements and B is having the different elements. We can't tell because this is not a subset. A is not a subset of B. Now we have to give some reason why. See, this is a reason. For a set to be a subset of another set, it needs to have all the elements present in the another set. Okay. Now A is having only we can match small a and small a in both the sets. But that is not the condition. The condition is what? If A to be a subset of B, all the elements of A should match the elements of B. Then only we can call it A as a subset of B. Here only small a is matching the set B. So don't get confused. We have to match all the elements of A to B. Okay, so this is not a subset. This is not A is not a subset, so it needs to have all the elements present in the another set. In set A, E, I, O, U elements are present, but these are not present in B, and hence A is not a subset of B. Next is B a subset of A? No. Why? See, again, for this condition also, the elements of the set B should be present in the set A. Set B is what? B, comma C, comma D. Elements are present, but these elements are not present in set A. Okay, hence B is not a subset of A. Now let's see the another example. Consider the sets. See, first is what? Our null set. Then A is the elements of A are 1 comma 3, B 1 comma 5 comma 9, C and C is the elements are 1 comma 3 comma 5 comma 7 comma 9. Insert the symbol subset or subset does not belongs to between each of the following pair of the sets. Now, first see the given exam. First condition, that is what we have to compare the null set and the set B. First, let's write the given equation. See here, null set is what? There is no elements. Then A is set, B, 3C we have written. Since null set is a subset of every element, we can write like this. See, therefore, null set is a subset of B. Okay. Our next question is, see, A, we have to compare A to B. What are the elements of A? 1, comma 3, and B is 1, comma 5, comma 9. We have to compare A and B here. See, in set A, 3 belongs to A, but 3 does not belongs to B. So A is not a subset of B. So A is not a subset of B, we have written. The next one, we have to see A and C. We write the element like this. A is equals to 1, comma 3, and C is what? 1, comma 3, comma 5, comma 7, comma 9. Since 1 or 3 in set A, okay, 1 and 3, and 1 and 3 is present in set C also. So all the elements of set A are in set C. So A is a subset of C. So the given set is, we have to compare B to C. So what is there in B? 1, comma 5, comma 9, and C 1, comma 3, comma 5, comma 7, comma 9. Okay. The elements 1, 5, 9 are in set B and are also in set C. Can you see 1, comma 5, comma 3? So all the elements of set B are in set C. So we can write it as B is a subset of C. Okay. I hope you are clear with the subset. Okay. I hope you have understood the subsets. Please do not forget to subscribe my channel, like and share my videos. Thank you.